Water Surplus is proud to announce ImpactRO, featuring NanoStack membranes, a revolutionary breakthrough in membrane separation technologies. By combining a series of milestone technological improvements into one efficient and sustainable system, the Water Surplus team has created an RO that delivers increased membrane life and membrane cleanability, higher system recoveries, and reduced energy consumption. All achieved through a high-efficiency design that predicts, prevents, and reverses membrane fouling. Here's how it works. NanoStack membranes are the foundation of our ImpactRO design philosophy, unlocking the highest efficiency reverse osmosis design protocol. NanoStack membranes feature a revolutionary NSF-certified membrane surface modification that harnesses a bio-inspired polymer, making our membranes super hydrophilic, or water-loving. NanoStack membranes are extraordinarily resistant to adhesion from scale and organic foulants, enabling contaminants to be repelled and swiftly flushed off the membrane surface during normal operation. NanoStack is a permanent surface modification that we can apply to any polymeric membrane element to minimize fouling, improve cleanability, and reduce energy consumption. Conventional brackish membranes have larger contact angles ranging from 45 to 70 degrees and limited hydrophilicity, which makes the membrane susceptible to permanent organic fouling and scale formation, resulting in decreased membrane life and increased offline cleanings, energy, and chemical consumption. NanoStack membranes have a 20 to 25 degree contact angle, creating a water barrier, resulting in fouling resistance and resilience, which increases membrane life, cleanability, and energy savings. When the membrane does need to be cleaned, ImpactRO's interventions allow NanoStack membranes to recover up to 100% of the original active membrane surface area. We call this full flux recovery. In traditional multi-stage brackish RO designs, the lead elements in the first stage are typically overfluxed, while the tail elements in the third stage are underfluxed due to limited cross-flow velocity. In layman's terms, the membranes in the first stage are overutilized, and the membranes in the last stage are underutilized. The RO design limitation requires excess energy, limits maximum recovery goals, and produces a steeper flux profile, often leading to irreversible membrane fouling. In comparison, our flux balancing design keeps the traditional cascading array, but diverts a portion of the RO feed water from the first stage to the second stage, where it is blended with the first stage of concentrate, delivering a higher feed pressure to the second stage. This effectively flattens the flux profile of the system array, reducing energy consumption and optimizing the utilization of every membrane in the system. This means that all elements in each stage of an ImpactRO are fluxed more evenly, enabling highly efficient utilization of the entire active membrane surface area across each membrane in the system, resulting in the most efficient operation of the RO system and maximized lifespan and performance of each NanoStack membrane. Our patented membrane micro-disruptions further address recovery limits and membrane fouling issues in conventional RO designs. In conventional three-stage brackish RO designs, especially in higher recovery applications, scale formation precipitates on the concentration polarization layer of the third stage elements, which limits cross-flow velocity and reduces the available active membrane surface area. Many times, this results in a major fouling event, followed by an offline cleaning. ImpactRO's micro-disruptions are intermittent periods of increased feed water volume and cross-flow velocity that clean the membranes in the final stage without disrupting operation. Optimized to work best with NanoStack membranes, micro-disruptions agitate the concentration polarization layer of the membranes in the final stage, sweeping scale and foulants off the NanoStack barrier, restoring optimal specific flux at the lowest operating pressure. All this happens while staying online and creating high-quality permeate. Micro-disruptions reduce overall energy consumption by restoring active membrane surface area and resetting specific flux, increasing membrane life, and maximizing system uptime. This real-time intervention is not just driven by ImpactRO's design parameters, but also by NanoScope, our direct membrane monitor for early onset fouling detection. NanoScope is a direct membrane monitor that detects previously undetectable performance loss in real time. Additionally, NanoScope uses predictive analytics to anticipate and prevent membrane fouling by alerting the operator or program to initiate ImpactRO's interventions such as micro-disruptions, which restore flux. In the field, NanoScope can detect fouling events up to 15 times faster than conventional instruments and system-wide KPIs. Within a conventional multi-stage RO system, overall system-wide key performance indicators such as pressure, flux, and permeate water quality are only indicators of the entire system's average. Usually a large number of membranes, all of which have variable operating conditions. Fouling events usually take longer to show up in traditional system-wide KPIs, making it almost impossible to implement fouling mitigation actions. RO systems foul in different ways. Scaling typically happens at tail-end membranes due to increasing mineral concentrations. Particle and biofouling typically occurs at the lead end of the membranes, which operate at higher flux rates. NanoScope is a patented direct membrane monitor that measures pressure, flux, and permeate quality of the most at-risk membranes, effectively detecting fouling indicators in real time. Before system-wide KPIs begin to change, NanoScope can detect and signal the operator and program to take mitigating interventions which can prevent and even reverse the fouling event. In summary, ImpactRO technology provides the following for operators, integrators, and end users: increased membrane life and performance, increased system recoveries, reduced energy consumption, steady state operation, accurate monitoring and telemetry for predicting, preventing, and reversing membrane fouling, flexible and intuitive interventions while remaining in efficient operation. Overcome your RO inefficiency with ImpactRO, the smartest RO for sustainable success.